Folks, let's do some experiments here today. Got some water on a stir plate. I'm going to add some universal indicator. You can see the colors that universal indicator displays over there on the right. So let's see. You might be able to see that it's got like a green color. So that's showing it's neutral, pH 7. We'll go ahead and add a little bit to this water here. How you doing there, Charlie? Just adding some universal indicator to our flask. Hello there, Bryson. Welcome aboard. I love how the dye pretty much stays concentrated in the center of the vortex. Love watching that. And that's a low pressure region. So, of course, material is going to tend to stay focused in that low pressure region. I think that might be enough color, huh? Let's find out. Looks like an alien abduction. Okay, here we go. Let's add a drop of, watch what happens. We're at neutral here. I'm going to start adding base. I'm going to add a single drop of base. In it goes. Looks like our pH went from 7 to 8 or maybe 9. I'm going to add another drop of base. There's another drop. And now we're at violet, so I think our pH is now at 10. You can tell the different pH values here. Now I'm going to go in the opposite direction by adding hydrochloric acid. Hydrochloric acid is the same acid that's found in your stomach. It's just the stuff that I add here is like 100 to 1,000 times more concentrated. All right, let's start adding a few. Lear, we're going to add hydrochloric acid instead. Here we go. Add a drop in there. That's a single drop of hydrochloric. You can kind of see the material staying concentrated in the center. You see that red line in there. That's from, the acid. But, of course, as it diffuses into, or I should say mixes into the bulk solution, the pH, the acid gets consumed. Let's add another drop of the acid. I think we're maybe down to a pH 9. We're going to add another drop of acid. There we go. Probably down to about a pH 8 right now. Yeah. Oh, we're going to do that, Lear. We're just going to keep adding drops of acid. I'll add another drop here. I think we've neutralized it. Maybe that's just a bit basic. I don't know. I think maybe that's neutral. Sure enough, I think that's neutral. We'll add another drop of acid. We're down from pH 7. We're going to get down to 6. What kind of base you want me to use? Very cool. Let's add another drop of acid. pH 6. Now we're down to, yeah, it's about pH 6. Let's keep adding some acid here. There's another drop. Boy, that's staying right there about 6. I'm going to add like 3 drops here. Wow, yeah. Sodium hydride, yeah, I don't have any of that. Not going to be adding any sodium hydride. Sorry about that. I don't have any. I think we're down to about a pH 5. Let's put another drop in there. So I'm adding acid, and the pH is dropping. Yeah, 4.7. I'll give it to you, Lear. Now we're at like pH 4, maybe 3. I don't have any of that Pirate King. A couple more drops of acid. We're at about pH 3 now. Sorry there, Special. I don't have any fluorantimonic acid. I probably wouldn't want to be using that in my basement anyway, eh? All right, let's add like 2 drops of sodium hydroxide. Let's see if we can't get that rainbow. Here we go. We're going to do that bracing right now. Hello there, ice bears. All right, here we go. 2 drops of base. Let's see what happens. 1, 2. Let's see if we can get that rainbow going on. There it is, baby. Little rainbow action for you today. Come on, man. That's beautiful. That was some beautiful, beautiful. All right, let's add a bit more base here. We're going to get that pH right up to pH 10. Thank you there, Ice Bear. It's spinning because it's on a magnetic stir plate, so that there's a magnetic stir bar in there. The indicator, Cody, is a mixture of 4 different indicators that we call universal indicator. Thank you there, Pirate. So these are the colors that it displays. Thank you there, Ice Bears. But universal indicator is actually a combination of 4 different indicators. There's some thymol blue in there. There's some methyl red, some bromothymol blue, and phenolphthalein. And so, for example, if you add all 4 of these together at pH 3, a deep red, a yellow, and a colorless, basically give you a red color overall. If we contrast that to, say, pH 10, at pH 10, a deep blue, a yellow, a deep blue, and a bit of a pink, that's going to give you your violet color. It does, Gabriel. I don't have any baking soda down here, but I do. Do I have any washing soda? Maybe I have some somewhere if I can find it. Okay, we're going to add let's add some hydrochloric acid. We'll see if we get that rainbow flash again. Here we go. I'm going to give it a good squirt of hydrochloric acid, and we're going to watch what happens. Hopefully we'll see it. There it is. Little flash of the rainbow, baby. On Terrace, it does show some... Hey, Ice Bears, thank you. Ice Bears just sent me $1. Come on, baby. Come on, Ice Bears. Appreciate the support. So, Antares, so one way this is similar, say, to a whirlpool is the outside. Well, let's just say the inside. The vortex portion, that's a low pressure region. So watch, if I add some base, which should turn this blue, I'll add a drop of base and watch. See how it kind of stays focused there in the middle? That should make sense. That blue color is going to stay in the middle. The material I add should stay focused in the middle because it's low pressure. And material stays in low pressure regions. Now, of course, when it gets down here to the bottom, when it gets down to the bottom here, that the stir bar is going to spread the material out along the sides. So it's not going to stay focused in the center forever. The atomic number game. So you mean like trying to test me if I have my elements memorized? Salaz, maybe it's good for you to just take a little break from your studies. I'm going to add some hydrochloric acid. Let's give it another squirt. Just another good squirt of hydrochloric acid. Thank you there, Cody. I appreciate that. Interesting. So, Cody, you can just buy a universal indicator. I don't make it myself. It's very inexpensive to buy. You can get like a half liter or a liter for somewhere around $10 to $20. Thank you there, Richie. Hey, thanks there, Raghav. How many elements do I have? I apologize. Iodine, that's number 54. They're very cools. I don't know what you mean there, LearnStan, by how many elements I have. All right, let's give a little drop here. Let's give like 2 drops of sodium hydroxide. See if we get the rainbow going on. Come on, baby. There it is. I've got the rainbow down today. Look at that. I'm at home, Salaz. I'm in my basement. Thank you there, Richie. We're going to go ahead and continue to add base. I want to get this all the way up to like a pH 10. So I'm going to continue to add drops of base. Here we go. Another drop. Raghav, what kind of questions you got on your chemistry exam? If it's organic chemistry, I'm not going to help you out. I've been too long since I took organic. How does the water change with the amount of acid, asks Gabriel. So how does the water change? So, hey, what's going on, administrator? So it works like this. We're going to imagine that there's just one indicator in here. Here, let me add a good squirt of acid here so we can see a little color change going on. So just imagine there's one indicator in there. There's really 4. It's not going to happen, Arsh. Curium. That's a tough one. Curium. Hydrogen helium. Well, let's see. It's going to go... francium, radium. Curium. Francium, radium. Actinium, proactinium. Americium, curium. So I think curium's going to be 96. I think I got that right. Electrochemistry and chemical kinetics. I can help out with a little bit of that. How you doing there, MR? Raghav, I can't help you with organic. Sorry about that. Thank you there, my Corp. No one. That's funny. Do I have a favorite atomic model? I do, administrator. It's the Bohr model. Let me tell you why. Because it's simple. I know it's not perfect, but man, you can learn a lot from the Bohr model. Very cool. I cannot recite the song, but I can recite all the elements in order. Francim is indeed 87. Don't drink, your eyes will go rainbow. Here we go. Let's make the rainbow. Come on, I saw rainbow. Here we go. Let's add 2 drops of sodium hydroxide. 1, 2. Hopefully we'll get the rainbow. And there it is. A little flash of rainbow for you. How do you start to learn chemistry? By learning general chemistry. Oh, administrator. I mean, if you want, I like Dirac's, relativistic model of the hydrogen atom for sure, but very cool. What I've done actually is I've changed the words to Johnny Cash's "I've Been Everywhere, Man." And instead of saying "I've been everywhere, man," it's "Chemistry's everywhere, man." And instead of saying names of cities in it, you say the names of the elements. So I've made up that song that I use instead of Tom Lehrer's song. Jonathan Clayton's organic chemistry book. Cool. The most complicated chemistry question I've ever come across. Wow. Yeah, let's add a couple drops of sodium hydroxide so we can get that rainbow going. 1, 2, 3. Let's give it go. Come on. It does. It looks like the Aurora Borealis for sure, like a rainbow version. Thanks. Thanks for hanging out there, Ice Bears. Why is it yellow is the hardest question. Well, I'm adding some acid now. Could I explain Faraday's law? Not without doing a little review first. I apologize. Or is Faraday's law just the fact that, a mole of electrons has 96,485 coulombs? Is that what you mean? Faraday here. I love it. Come on, Faraday. Faraday's infinity. Aurora. Yep, we're back to acid now. Okay, I'm going to go ahead and add a couple drops of base. Let's see if we can, we're at pH 3 now. I'm going to add a couple drops of base. We're going to see what happens. The pH is going to go up, but we're going to see if we can't get a flash of the rainbow as it goes up. 1, 2, 3. 3 drops. Let's watch it. There it is. We got the rainbow flash, folks. I love that. I love it. Thank you there, Faraday. And it looks like I added enough base. And notice, as the reaction goes, you're going to see a lot of different colors. Tanish, you need to just do problems. Looks like we got our pH at about 9 or 10. Thank you there, Core. Thank you there, Kid Crash. Yeah, maybe pH 9, Kid Crash. All right, I'm going to give it a good squirt of hydrochloric acid. Hydrochloric acid is also known as stomach acid. It's just that this stuff here is like 100 to 1,000 times more concentrated than what's found in your stomach. Here we go. Let's add a difference between coordination sphere and a complex ion. A coordination sphere, that's just going to be the molecules and ions that directly surround a particular ion. A complex ion, that's going to be the formula, or the chemical species that is going to be dissolved in solution. I don't mess with arsenic. How's the glass not melting? Hydrochloric acid does not react with glass appreciably. Neither does sodium hydroxide. So I'm going to start adding drops of acid here. So here we go. You can notice that as I'm dropping in the hydrochloric acid. Oh, arsenic. I think that's 33. Very cool. Sorry about that. Hey, Squid Game. There we go. So as I dropped in the hydrochloric acid, you can see the color changes to red. Yeah, I'm adding stuff from above. Salah. So here, okay. So here's how things, here, let me do this. I'm going to turn this off so you can watch something happening while I blather on about how the substances change color. So here we go. I'm going to go ahead and add some sodium hydroxide solution. Let's give like, I don't know, 1, 2, 3, 4 drops. Okay, so let's just pretend that the only indicator in here, there's 4 of them that give all the different colors, but let's just pretend the only one that's in here is phenolphthalein, which is either colorless or pink, okay? That's it. And phenolphthalein happens to have a ring. Oh boy, that's gorgeous, isn't it? It happens that you have a good day too, Squid. So it has a ring-shaped structure like this. And it only takes on a ring-shaped structure when there's lots of protons around, H+ ions. See what happens? You can think of it this way, that the phenolphthalein molecule grabs onto those protons, and when it does so, it makes a ring, like that. And there's only a lot of protons around when there's a lot of acid. So this is going to occur when, you're in the pH, say, 6 to 3 zone. So there's a lot of protons around. There's a lot of phenolphthalein molecules that have this ring-shaped structure. And when they have this ring-shaped structure, they're colorless. Now, when you add bases grab those protons. They take them away. So when you add base to the solution, the protons are taken away from the phenolphthalein molecule, and that makes it go doink. It pops open. And when it pops open, it goes from colorless to colored. And that's why phenolphthalein shows these different colors, colorless or colored, colorless at low pH when there's a lot of protons around, pink at high pH when there's not many protons around. And that's how that one individual molecule changes colors depending upon pH. Now, the other ones do similar things, but they're different structures and different things going on. But it's just a color-structure relationship at different pH. All right, that was pretty cool color change we saw in there. Yeah, I might be wrong, Shadow. You're right. I might be wrong. Here we go. All right, let's go ahead and add a couple drops of acid here. Thanks, Air Chimera. I appreciate that. Let's give it a big squirt, see if we can get a rainbow flash. Football, we're just doing some color changes with acid-base indicators. I agree, Faraday. Sorry, I had to put somebody in timeout. I got tired of seeing their comments. I haven't watched someone do science in 10 years. Cool, Albie. Hope you're going to enjoy this. Okay, I'm going to add some hydrochloric acid now. Tanish, the difference between a pH indicator and a redox indicator, a pH indicator is going to change colors depending upon the concentration of protons, these H+ ions. Indeed, Skylar, phenolphthalein definitely used to be used as a laxative. A redox indicator, that's going to change color depending upon the amount of oxidizing material that's present in the solution. Agreed, Faraday. Let's slow it down and check it out just a bit, shall we? We're going to check out the vortex current, okay? All right, I'm going to add some drops of sodium hydroxide. We'll do 2 drops. You'll notice that it tends to stay concentrated in the middle, but we're also getting a flash of that rainbow, man. That is just beautiful. Great to hear it, Raphael. Thank you. Appreciate that. Yeah, you can see that low pressure, that straight low pressure zone straight down the vortex. Very cool. I don't have the golden penny stuff with me. Apologize. I don't have a heating unit and pennies ready for that. So I'm not going to be able to do that on the stream today. Although, you know what we could do. I haven't done this in a while. Hey, Trophy. It might be fun to do a little bit of the, little fun to do the glitter stuff today. The difference between an Arrhenius acid base and the Bronsted-Lowry. So an Arrhenius acid is going to be a substance that increases the H+ concentration in solution. So for example, carbon dioxide, CO2, is an Arrhenius acid because when you dissolve carbon dioxide in water, the two react. Here, I'll write out the reaction here. CO2 plus water. And it goes to bicarbonate and what? And the H plus ion. So there. So carbon dioxide is an Arrhenius acid because when it dissolves in water, it increases the concentration of protons through this chemical reaction. Now, Bronsted acid, those are proton donors. And carbon dioxide doesn't have a proton. So it can't be considered a Bronsted acid because it has no proton to donate. That's it. That's pretty much the idea. Or I should say an example. Very nice, very cool. So here we go. Let's add a squirt of hydrochloric acid. Kid Crash has added their favorite element to the chat. Why don't anybody add their favorite element to the chat? Let's see what they are. Looks like Kid Crash's favorite is carbon. Mine happens to be hydrogen. Charlie wishes they had these kinds of streams when they were in school. You got it, FG. I'm going to keep adding acid here. Radium. Donnie likes some radium. If I remember correctly, radium is element 88. Tungsten and cesium. Ha! So Ricky almost passed out doing the dissection of the pig's heart. We got a neon. We got to vote for Organoson, number 118. We got to vote for uranium, number 92. We got xenon, if I remember correctly. Ooh, xenon, is that 54? I don't have, well, actually, I do have some turmeric. Adamantium, a little bit of a fictional element there. Thank you there, Rev. We got a cobalt vote. All right, let's add 3 drops. 1, 2, 3. 3 drops of base. Uranium-235. There we go, a little rainbow shot. Little rainbow shot for you. Vibranium, another fictional element. Ethyl acetate and water. Will it separate in 2 layers? Gold. We got to vote for gold. We got to vote for zinc. Thank you there, Telios. Let's keep adding some sodium hydroxide. You'll watch the pH go up. There we go. We're at like a pH 10. So long, Salaz. Thanks for hanging out. Let's give it a squirt of hydrochloric acid. See if we can see a little rainbow action. Give it another shot there. Let's find out. Gallium is definitely very cool. Lithium is interesting. There it is! Although it didn't work real well. Let's give it another shot here. See if we can get a little rainbow action going there. Extra spicy. We got to vote for mercury there from Dominic. Mercury's element number 80. All right, let's keep adding some hydrochloric acid here. A couple drops. Let's get that pH down good and low. Silicon. It is pretty cool, DeLeon, Charlie. All right, we're down to pH 3. I'm not going to add drops of sodium hydroxide solution. That's going to, form a higher pH, and we'll watch a bunch of colors as it gets there. Here we go. Let's go 3 drops. Watch what happens. 3 drops of sodium hydroxide base, and there it is. Look at that, gorgeous. Look at all the colors of the rainbow, man. That's cool. Alexander's vote for tungsten. Got another fictitious element from Jay. Anobtainium. I think they probably meant unobtainium, but I'm not sure. So FG, a Bronsted-Lowry definition of the acid is more general than Arrhenius. So it can cover more acidic behavior, so to speak. The most I don't want to say the most because I'm not up to date on it, but what we teach in general chemistry is the most general theory of acids and bases is Lewis acid-base theory. Polonium and molybdenum, element 115. I think that's nihonium, Jay. Hello there, Diglett. Uh-oh, very cool. Has got a bunch of favorites. Helium, lithium, neon, aluminum, argon, calcium, iron, copper, zinc, gallium, and a bunch more. Hello there, Junior. Hello there, Terry. Would red mercury be a fictitious element? I believe it is. Although mercury is a real thing. All right, Trophy wants me to try to make this light green. We're going to try it. Hey, Nick, you can go ahead and leave, or I'll just block you. You and I both know why. Let's get rid of him. Could I show what happens if I mix ammonia and some? Yeah, you can check out my Veal Play. You can check out my some of my YouTube shorts. I do a video where I mix acid and bleach. It's not something that you want to do. I did it in a hood. We're trying to make it light green right now. I think I pulled that off. Hello there, Joe. Welcome aboard. I do not. Thank you there, BRM. That is indeed what I'm doing there, Evelyn. If you look right now, Evelyn, I am mixing sodium hydroxide solution and hydrochloric acid solution. And when you do this, when you mix sodium hydroxide solution and let me do it this way, and hydrochloric acid solution, the H from the hydrochloric acid and the OH from the sodium hydroxide, they combine and they make HOH, which is water. And on the other side, the sodium from the sodium hydroxide and the chloride, I should say, from the hydrochloric acid, those combine and make sodium chloride, which is salt. So I'm making salt water. All right, Richies, I got it. I got your green. We got the neutral. How you doing there, gaming? Jack, if you watch carefully, I'm adding these things right here, okay? I'm adding solutions. Here we go. Let's add a couple drops of acid, hydrochloric acid. You can see me adding up here at the top. Thank you there, Shasha. See if I've added enough to get the pH down to 3. I don't think I have. Let's add a few more. 3 more drops. Great to see you aboard, Shasha. Looks like we got a nice pH of 3. Let's add 1 more drop. Just 1 more. There we go. The indicator I'm using, cyanide, is universal indicator. This stuff here. Hey, Paralot. Welcome aboard. Sorry if I'm saying that wrong. All right, I'm going to add 3 drops of sodium hydroxide up here at the top. You can see it going in. 1, 2, 3. Let's hope you get the rainbow, baby. There it is. Come on, we made it. Come on, that's beautiful. Hello there, Furry. Thank you there, Cyanide. Boy, that's persisted for quite some time. That was pretty. I like that. I'm going to try that again. Thank you there, It's. Are there any dual stable states with universal indicator? Donnie, I'm not going to claim that I completely understand what you're asking. But if you're asking me if there's kind of like 2 different colors that can persist at the same time, that's a little too deep to answer. I would say yes, but it's I'd need to go into some detail with you there. Okay, can we go back and forth between acid and base? Is there a certain point where there is a molecule saturation and the reaction stops or becomes less sensitive? Or can this go indefinitely? This can go on indefinitely, but I will say this, that, for example, once it hits red, Once this indicator system hits red, as you continue to lower the pH, everything stays red. And again, on the higher end, once you hit purple, as you continue to raise the pH to 11, 12, 13, 14, it's going to stay violet. So, all right, here we go. Let's go 3 drops. Maybe 4. Oh, I just added acid like an idiot. All right, let's try adding 6 drops of base. Let's do like 4. Let's see if this goes. I think it's a Vortex, Lumco. Got a little rainbow action going on there. I like it. Pretty cool. Kind of beautiful. Gaming. I'm not going to add all the chemicals I have, but I can add both the sodium hydroxide and the hydrochloric acid at the same time. That's kind of fun to do. Hey, let's do this. Let's make it acidic. This is kind of fun to see. Thank you there, Dominic. Appreciate it. I do, but not here with me. So I do these live streams in my basement. So everything I'm using is like kind of safe to use at home. If you got the right precautions like gloves and goggles and stuff like that. All right, I've got this low pH. Now notice I turned off the stir bar. Gaming Fishy wants me to try to make it yellow. What I'm going to do while it's turned off is I'm going to add 6 drops of sodium hydroxide. We're just going to watch what happens. We're just going to watch what happens. Can I do increased speed? Yeah, we can try that. Let's add a little acid here. I think I got too much base in there. Let me just get a good squirt of acid in there and just look at that gorgeous, like, just all those different colors. Very cool. Thank you there, Dominic. All right, let's go ahead and turn this back on. Somebody wanted me to like really turn up the speed, I think, here. So I'm going to try to do that. There's your yellow, baby, down there at the bottom. Oh, no, I'm going to have to add a little bit of acid. Let's get this going yellow. Somebody wanted that to go yellow. We're going to get this yellow. Come on now. Come on. There we go. I think we got it. No, Skull Munch, you can actually have a negative pH. You can do that. Delina, welcome aboard. Hello there, AE Master. Purple says Big O's. Let's give you a shot here. Gonna add some. There you go. Couple drops. And there's your violet. Violet's pretty easy to get because at pH 10 and up. Do I have any other bases? I have some ammonia over here, but I don't want to be adding a bunch of ammonia. It smells. Thank you there, Toby. What are you measuring that has negative pH? Donnie, this stuff right here would have negative pH. So this has got like a 3 molar concentration of hydrochloric acid, which would roughly be like a negative pH -1, roughly speaking. Hydrofluoric acid, AE Master, will indeed react with glass, but I'm not using hydrofluoric acid. So cyanide, if I used lemon instead, the same thing could happen. The issue is you'd get like citric acid. You'd get different forms of citric acid that would buffer the mixture, and what that would mean is it would lock the pH in at certain pH units and make it difficult to change the pH. Dark red, let's do it. To get dark red, I'm going to add a bunch of acid, right? If I add acid, the pH should drop. So here we go. Could I stick my bare hand in it safely? I could. I mean, this isn't that crazy. Hey, thank you there, Lucas. I'm looking forward to it, Faraday. What kind of visualizations you talking about? I don't have any sulfuric acid with me, Uncle Munich. I apologize. So Bigos, if we go pH 1 or 2, it's going to stay this color. It's going to stay red at pH 2 and down. Lucas, so I am adding a solution of lye. Sodium hydroxide is known as lye. I'm just using some that's been dissolved in water. Here you go. I'll add a little bit up here at the top. You can see we're at pH 3. Watch what happens when I add 4 drops of sodium hydroxide solution. Thank you there, Dominic. Well, thanks for hanging out. And there's our rainbow. Come on, folks. Okay, Faraday, that'd be cool. That'd be really cool. Thank you there, Sasi. So Prasad wants to make different layers of color. Let's try that. Let's try to making this. Hey, thank you there, Grave Digger. Thank you there, Everyday. Okay, we're going to get 2 set up here. So let me get another one going because people want to see some layers. What kind of acid do they use to test gold, silver, and platinum? You can use nitric acid for that. Nitric acid will react with silver, but not platinum and gold. A mixture of hydrochloric acid and nitric acid will dissolve gold. Let's get this one set up here, okay? We're gonna let me get the pH in this one down a bit. And we're just a little bit of acid over there. Okay, on this flask over here, you'll notice I have a slightly smaller stir bar. It's kind of tiny, actually. It's even kind of really hard to see. See it down there at the bottom? All right, we're gonna get that little guy spinning. I'm gonna pour in some water. You guys can watch how I do this. Because I saw someone ask how do I do it. So it's just water on a stir plate. That's all I got going on. Now what I'm going to do is I'm going to add some universal indicator. Thanks there, Doggerel. Appreciate the love. So here we go. Universal indicator. You can buy that stuff for like 10, 20 bucks online. Now I got to add my universal indicator solution, which is pH 7 neutral. Hello there, hi. Forbidden orange juice, I love it. Orange sunset. Here we go. You can see the universal indicator's got a green color. But when I add it to purified water, it takes on a yellow color, which is slightly acidic. That's correct, AE Master. Now, if you want to know why purified water is slightly acidic, you can actually check out the video, the shorts video I just dropped this morning. So give that a check out, and you can understand, if you check it out, you can understand some of the science behind why purified water is slightly acidic. There's actually some carbon dioxide dissolved in there, and that's what makes it acidic. You can see some experiments on how that happens. This side's going to take a little longer for the color to mix in because I've got such a stinking small stir bar. Let's really get this guy jacked up. At work, Skull Munch uses nitric acid and quicklime to make liquid fertilizer, calcium nitrate. Makes sense. And when dosing it, the pH drops into the -1 about 12 times before it reaches the desired pH of 5 to 7. Interesting. Make it bigger, says Lane. All right, I've got that stir bar jacked all the way up. Thank you there, Elisa. That little guy right there is doing all the work of the spinning here. Look at that little guy just spinning around like crazy. Look at how big this one is by comparison. This is actually spinning a lot faster than it looks like in the video. It's just that the frame rate in the video is making it look like it's spinning slow. All right, so here we go. Let's do like a drop of bass over here on the right and just watch what happens. Here we go. Put a little drop in there. Boop. And it goes. Look at that. Come on, that's cool. That is just gorgeous. That was pretty. Very pretty. I agree there, Donnie. Man, look at it in there. It's like you can, that is really weird. That is so stinking weird. I love it. Thank you there, Cyanide. Sunset and night. Okay, let's add some acid over here on the right. Let's go like 2 drops. 1, 2. So that should lower the pH. So the change in color is a result of the change in molecular structure, which changes how electrons interact with light. You got it, it's Danielson. You got it. You absolutely have it. Now, there's 4 different dyes in the universal indicator. So, you know, there's 4 different structural changes that are going to occur with pH. But yeah, you got the basic idea. Let's add a little drop of base over here on the left. You see the changes happen much more quickly on the left with the larger stir bar. And they happen much more slowly on the right. So you get a more layered effect that lasts. All right, let's acidify both sides. Gonna need some more acid over here to acidify it. Here's the different pH values that you will see. Right there, down there in the middle. Thank you there, Ryan. I appreciate it. No stirring, bigos. You want the right side or the left side? So, Salma, how it works is like this. There are 4 different dyes in here. In the same 4 different dyes. Thymol blue, methyl red, bromothymol blue, and phenolphthalein. The acids and bases I'm using, Doggerel, are sodium hydroxide and hydrochloric acid. When you add them together, they show these different colors at different pH values. And all pH is how acidic or basic something is. So if I add a bunch of acid over here, the pH is going to drop. So it's like pH 6 right now. When I add acid, the pH gets lower. So we went from like a pH 6 maybe to a pH 5. I'm going to add a bit more acid. And now we went from a pH 5 down to a pH 4. As I continue to add acid, we'll go pH 4 down to pH 3. Very cool. Those are synonymous. Just synonyms. Okay, now I'm going to add a couple drops of sodium hydroxide solution, which is a base that's going to raise the pH. But the nice thing about it is it takes a while for the base to mix through the solution. So the reactions will happen that'll neutralize the acid. And that'll, you know, anytime an acid and base combine, they neutralize each other. So they bring the pH closer to 7. But the reaction happens at different rates in different regions in the flask. And because of that, you get a whole bunch of different colors. Here we go. Let's go like 1, 2, 3 drops over here. 1, 2, 3 drops over here. Now, the faster stir speed over there on the left, look at that rainbow. Allows you to see a rainbow that sort of homogenizes quite quickly. Boy, on the right, it just kind of, let me add a few more drops of acid over there. And yeah, look at that. We got pretty close to pH 6 after adding the acid and base together. Good to see you, Tara Chad. All right, let's add some hydrochloric acid here. Boom, 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 boom. Let's see what goes on over there. You can see the red right there in the middle. It's like daytime on the bottom, nighttime on the top. Kind of cool. I think I'm going to acidify this side over here. So why do the colors change? So Salma, I'm going to give you a lowdown on one of these indicators, okay? I'm not going to talk about all of them. But the one indicator that's in the mixture is called phenolphthalein, which is either colorless in acid or it's colored in a base, okay? Colorless in acid, colored in base. And it works like this. When there's a lot of acid around, acids donate protons or H plus ions to a solution. All right? So when I add acid, I'm adding a bunch of protons here. And when I do that to a phenolphthalein solution, the phenolphthalein molecules come along and they grab onto this. And when they do, they make a ring shape, just like I'm showing here. And molecules of phenolphthalein that have this ring-shaped structure, they are colorless. Now, when I add a bunch of base, like what you're seeing here, I'm adding a bunch of base. There you go. Let's just watch those color changes happen before we talk about what happens. Come on, a little rainbow over there on the left. You can do it. You can do it. I think we got it. Little rainbow action. I love it. Anyway, when you have a lot of base around, bases grab onto these protons. They chemically take them away. And when that happens to phenolphthalein, it goes from ring-shaped like this, doink, to open like this. And with that change in structure from circular to open comes a change in color. Colorless, colored. Colorless and acid, colored and base. Colorless and acid, colored and base. That's how phenolphthalein works, and the other ones work similarly. Here we go. Let's add some drops of base over here on the left. Maybe, Doggerel. Doggerel, maybe you know some fluid dynamics of which I'm unaware is what it really sounds like. Thank you there, Bigos. Doctors, neither of them decay over time as far as I can tell. I usually acidify the mixtures when I store them. I just, put a lid on the top and then I store them. I do that because I've noticed if I have a higher pH, then bacteria tends to grow in the flasks. And then I got to, clean them out and take care of the solutions and all that stuff. Thank you there, Salma. Thank you there, Lameth Son. Now you're not overcomplicating things, Tara Chad. Protons indeed like to attract to negatively charged things indeed. And then that's, a discussion of how protons bind to things preferentially in some cases and not in others. That, that involves a more nuanced discussion of chemistry that I'm going to struggle to be able to do here on a TikTok, or excuse me, on a YouTube live. Well, that's true about everything, right, Bigos? I mean, everything's nice until you get injured. Hello, we are just doing acid-base reactions, little color changes. Yeah, a couple drops over here. A couple drops over here. I added acid to both flasks. You can see how the color change. Yeah, you can say that, Coblos. Oh, dysprosium. You got me on that one. Hold on a second. Dysprosium. Let's see. 54. Iodine. Xenon. Cesium, barium. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium. Dysprosium. Is that right? I'm thinking 64. What's my favorite demonstration to do? I did make a green color, Lamison. Ramiro, my favorite demonstration to do is whichever one I'm doing at the time. So in this case, it's the rainbow demonstration. I was off a little bit. You got me, very cools. What happens if you drink it? Michael, what happens if I drink this is I would guess that the live stream would end in maybe 10 or 15 minutes because one of the dyes in here is phenolphthalein, and phenolphthalein used to be the main ingredient in X-Lax. So, drop the emoji in the chat that would say what would happen if I drank this stuff. Hey, Raphael, thanks for being a member. Appreciate that. Appreciate that big time. Appreciate the support. Tara Chad. Drip gum, I love it. Exactly, Bigos. Thank you there, Richie J's. All right, let's add some acid over here on the left. Rhodium. Let's see. Oh, gosh. Rhodium. Oh. Let's see. Yeah, I see all the chats. I see all the emojis. Rhodium. Let's see. Actinium, thorium. No, that's too high. Let's see. Cesium, barium, lanthanum, cerium. Hafnium, tantalum, tungsten, rhenium. I don't know. You got me on rhodium. I could do it if I just was able to say the periodic table in order from the start, but you got me on rhodium. Donnie, you could hypothetically keep going back and forth. If I use hydrochloric acid and sodium hydroxide and the safest indicator on that list, could you maybe drink it? So Tara Chad, if I perfectly balanced the amount of sodium hydroxide and hydrochloric acid that I added, I would indeed make salt water. And then if I use a natural indicator from, say, cabbage juice, yeah, I wouldn't have any trouble drinking it. Which element intrigues me the most? Prasad, I'd got to say hydrogen. We need a rainbow race. Richie, this rainbow is working like crazy. It's just really working well. Rubidium, strontium, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium. Rubidium, strontium, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium. So it's going to be 45. Thanks for the hint. Thanks for the hint, baby. Thanks, very cools. Have I ever tasted sodium hydroxide? Universe, I have. Have you? That's somebody who's worked in a lab before is my guess. What about, good idea there, Big O's. What about adding pH plus and pH minus at the same time? Yeah, they interact UESE and electrochemistry. Okay, here we go. I'm going to try to get this over here on the left to be green. That's pretty close to green. And now I'm going to add, on this side, we're going to add hydrochloric acid, which will drop the pH. And on this side, the left side of the left side, we're going to add sodium hydroxide. That makes the pH go up. Here we go. We're going to do a drop of the acid first. 1, 2, drop of the base. 1. 1, 2 of the acid. 1 of the base. 1, 2, 3 of the acid. I'm adding more acid because it's less concentrated. 1, 2, 3, 4 of the acid. 1 of the base right there in the middle. Let's add another 1 of the base. Get a little squirt of the acid there. Another bit more. Look at that. We got some rainbow action, baby. Come on now. So what do you mean by a transition gas? What does that mean, Tara Chad? I've not heard that. Yeah, I'm loving hydrogen too, Tara Chad. What's a transition gas? I've never heard that phrase before. Come on, teach me some chemistry here, Tara Chad. Come on, Tara Chad. I love it when this happens. Tungsten. Why do you like tungsten, universe? Oxygen's overrated. Guess the Morse code element. Oh my God. Well, it's got 5. It looks like it's got 5 letters. Boron. I'm guessing boron, very cools. Because it's got 5 letters. Boom. Oh, we are getting some cool color changes today. Ah, radon, I missed it. I don't have any, Big O, sorry. All right, we're getting at the point in the live when I'm going to flip the camera around and talk to y'all for a little bit. I usually do that near the end of the live. If that's not something you want to see, now's your time to exit. You're going to see some old man in his basement. If that's not something you're interested in, then, you know, I'm just letting you know. Now you might want to go do something else. But if you want to see, I got my disguise on for you though today. I got a little oh, that was beautiful. That pattern over there on the right. Got a little cosplay to go on today. Thank you there, Big O's. All metal is aged acid ice. What do you mean by that, Shadow? Any advice for turning 18? Ask Michael the cat. What do you guys think? What's got some advice for someone who's getting ready to turn 18? Enjoy it, baby. It's fun being 18. Life is simple. What does this experiment show? It shows that you can control the colors of compounds with pH. Be yourself. I love it. Yes, Cyanide, I am a chemistry teacher, indeed. Smoking's overrated. Don't drink booze. These are great. These are great, man. Life's tough. Buy a helmet. I call it the rainbow experiment. Hello there, Matri. Atomic number of germanium. It's like 32, I think. Avoid credit cards. Or, hey, if you don't want to avoid credit cards, pay them off every month. Don't drink random liquids in the lab. I'm loving the advice. Come on, Raphael. Compound interest. Save early and often. I love it. Oh, we got a little rainbow over there on the left. Loved it. Love it. Dividends pay over time. How to make gold with copper? You're going to need some nuclear changes there. You're going to need some nuclear going on. A lot of nuclear. What's the most dangerous things I've made in life? I made some piranha solution once. You can check out the video of where I made some piranha solution. That's pretty dangerous. I think germanium's 32 there, Terra Chad. All right. Have I heard of magnesium phosphate cement? No, I haven't. I am, Selma. I am a chemistry teacher. Well, I don't think I got my sunglasses today, but that'll be all right. I still got most of it. Oh, no, I do. I actually do. Let's put these on, baby. Come on now. Time to turn the camera around. United States. Fermium's atomic number. Walter, yeah, indeed. Fermium's like 101, 102. Hello there, Bigos. We did some chemistry in the lab today. I need to make one of these blue. Yeah, Salma, I teach it in my school. Fermium's 100. Got it. I'm not the original. I'm definitely not the original. But I like dressing up like Walter from time to time. That was my grandfather's name of all things, Walter. Combative one. I have done a shorts video on the BZ reaction. Bismuth is indeed radioactive. Skylar, I teach at a university. Indeed, very cools. Haha, Cyanide, you got it. You got it. I like dressing up like Walter every once in a while. I even kept a little bit of the goatee for y'all today. That's correct, Terra Chad. No stable isotopes of technetium. Thanks for hanging out, combative one. That's right. Promethium's another one. No, Prasad, I cannot, and I wouldn't anyway. I need a guitar. Oh, man, I tell you what, folks, it's been good hanging out with y'all today. Good hanging out with y'all today. I think I'm going to take off, all right? I do not, Dango. None of that in my basement. Nope. Thank you there, Richie J's. We had a good time today. So all I used was water, universal indicator, 20% by weight sodium hydroxide, 20% by weight hydrochloric acid. Matt, welcome aboard. Sorry we're taking off. Have a nice day, everybody. See you next time. I usually do these on Saturdays or Sundays. I've been tending towards Sundays more lately. Get out there, check out my shorts on my channel, Tommy Technetium. Please share the channel if you would. I got a long way to go to 1 million, but we're at 700,000. You guys might help me get all the way to 1 million. I think that'd be cool if we could get there together. So thanks for hanging out today. Share the channel with your friends that like science, with your friends that like chemistry. Let me know when you see me in the comments. Great hanging out with you today, and we're going to see you next time. So long, folks.